Thanks, Mike. And now our hostesses will hopefully pass amongst you to offer you a celebratory drink with which we'd like you to hang on to, as we'll propose a toast after we've heard from our final speaker, who is the designer of the control system for our CESA unit, Mr. Marco Cucinotta. Now, Marco is an electronics engineering graduate with more than 18 years of experience of control systems design and development. He was previously senior engineer with Daewoo Motor Company, TWR Engineering and Menard Engineering, responsible for test and development and prototype build areas. So, Marco Cucinotta.
Okay, I'll try and keep this simple because the control system is fairly complex, but as Mike and Abdul said, the process that we're controlling is really quite simple. We're taking the waste exhaust heat from a landfill gas engine, we're using that heat to make steam in our own design of heat exchanger. The steam is turning a generator, making electricity, which we're feeding back into the national grid, for which we get paid. The control system, which occupies the front area of the unit, basically controls that process. So in the first stage, we control the making of the steam. The hot waste exhaust gas that's normally just blown into the atmosphere is forced to pass through our heat exchanger. As it passes through, we inject water at a controlled rate, and that water is heated by this exhaust gas passing through and generates steam. So that's the first stage. We control the generation of the steam. This steam is then fed into our steam engine, our modern-day steam engine. We control the starting of this. It has a fairly complex startup routine. We have to warm it before we can actually start. But in essence, the steam we make is used in this steam engine, which turns an electrical generator. The generator goes on to form electricity, which we feed into the grid. But the steam, when it's passed through this expander, through our steam engine, is still in a form of steam. So as Mike says, we use this condenser which converts the steam back to water, ready to start the whole process again. The power generation side is run by a control unit that takes the electricity from our generator and converts it into a form suitable for feeding into the national grid. There are quite strict constraints on the kind of electricity we put into the grid, and we have to be in perfect synchronization with the grid itself before we are allowed to inject any electricity. So a chunk of the control system looks after that process. It monitors the safety of the connection, it monitors the synchronization, and it monitors the amount of power we put into the grid. As this is a prototype system, we have a prototype control system. So the units are overly large, but we have built in a lot of capacity because this is our first prototype and it's also our first in-field development unit. So we want to monitor every parameter. So we have over 7 individual computers within the system monitoring up to 60 different temperatures, pressures and speeds. And these components are fully remotely accessible. We can talk to this over the internet, we can monitor the performance of it. The unit can send messages when temperatures are too high, when pressures are out of ranges that we deem acceptable. So it's a complex system, and ultimately it will be condensed down to a much smaller version, more akin to the engine management unit in your car. But basically, for a prototype system, we need a prototype control system. And the unit we have will monitor the safety, the performance, and hopefully through field testing we'll be able to predict the life of components and also indicate when service is required on certain areas of the system.